two types of teachers when it comes to graphing. Oh, come over here. I need you over there. Ah, stop it now. They're all super smart. There are teachers who want specific precision, right? And what they are going to want you to do, we're watching me. Jackson's watching. They like a lot of T-chart action, right? They want a T-chart. They want you to plug in points. And that's great. But I don't love that. And I'm going to tell you why I don't love that. Because if you ever make a negative issue, like you make one thing wrong, your graph goes to hell, right? So it's really hard to have a mom who's a math teacher when you take math classes. So my kids would come in home and they'd be like, my teacher graded this wrong. And I'm like, no, you were dumbass, you made a mistake. So my daughter was taking pre-calc. She got like a bunch of points off on a graph. She goes, I graphed it perfect. And she showed me her whole T-chart. And sure enough, she got 1 point wrong. And when she graphed it, it ruined the whole graph, right? But that's one way to do it, right? I like precision, but I'm a big believer. If we want a perfect graph, why not use technology, right? We'll use technology. The other way to graph is to use transformations. Now, I'll be honest. You don't get today, tomorrow, the next day, we're going to not get perfect graphs. We're going to get what I'm going to refer to from here on out as sketches, right? But a sketch gives you a ton of information. It's going to help you on multiple choice tests. It gives you so much information, and it's very, very quick, right? Because it's not about precision. It's about, hey, can I get a pretty good idea of what this looks like? So in order to use this method, we've got to know what everyone's job is in an equation. So today, at the very end of this period, you will be graphing this dude right here. And you'll do it in seconds. Like literally, it will take you probably 15 seconds to do that, right? Because doing this would be a nightmare, right? It would be a nightmare to do. But once I show you what, or remind you, because you did this in Algebra 2 and Algebra 2 trig, once I remind you what everyone's job is, it makes this super fast. So we're going to do this for the next 4 days. We're going to start with the absolute value graph today because it's easy and I want to get your brains going. Tomorrow, we're going to use the U graph, parabolas. We're going to use this graph, which is called a cubic. We're going to use a square root graph, and we're going to use an exponential graph. We're going to do all of these funky shapes, but once we know how to move them around, it's so easy. Is everybody cool with that? So the first thing that we need to know is, what does home base look like? So on your paper where it says parent graph, let's start with home base for today. Home base for today is this dude. F of x equals the absolute value of x. That's our home base graph, right? And then we're just going to move this dude around. So we have to remember what he looks like. And I'm going to remind you what he looks like, right? So he looks like this. And I'm going to go and make, you don't have to make a little chart. This is the only one I'll do, is to remind you the shape. If you've all seen Ferris Bueller's Day Off, that is Ferris Bueller. This is the Ferris Bueller's Day Off graph. And let me tell you why. Because what absolute value means is distance. You think, well, what does that have to do with Ferris Bueller? So Ferris Bueller drove Cameron's dad's car, and they put a bunch of miles on it. And then they wanted to make certain that the dad didn't catch them. So what did they do? Does anyone remember?
They drove it off into
yeah, they did. But what they tried to do was put it up on blocks, put it in reverse, and take the miles off, right? Did that work before they crashed the car? No. As a matter of fact, if you do that, it will add more miles onto your car. Did you know that? Right? Because if you go forward 10 miles and then you drive in reverse 10 miles, do you know how far you've driven? 20 miles. The car doesn't care if it's forward or backwards. You're driving either way. That's absolute value. Absolute value wants to know, how far are you from 0? So watch this. If I'm going to say 0, 0, we're starting right here. So on your little graph, let's graph this point 0, 0 for me right here. Boom, we're starting here. Then what I say is this. How many jumps is 1 from 0? It is 1 jump away from 0. 1, 1. How many jumps is 2 from 0? It is 2 jumps away. 2, 2. How many jumps is 3 from 0? 3 jumps. 3, 3. But here's where absolute value gets a little funky. How many jumps is -1 from 0? It's 1. You can't do negative jumps. You can't like jump into the ground. It's 1 jump away. That's what absolute value means. It's just talking about distance. It's saying, hey, don't worry about the negative or positive, just how many jumps. So if you're if you go -2, that's 2 jumps away. And that's why the absolute value graph looks like this, right? We're going to refer to this tonight as our parent graph. That's our home base. That's our home base. And it's got some important parts to it. So the first important part we're going to talk about is today I'm going to call this point right here the vertex, but we're going to change the name of that. That is 0, 0. We're going to call it from here on out, ooh, new word here, inflection point. And an inflection point is a point where your graph changes direction. Look, he's cruising. You get to 0, 0. He's like, oh, let's go up now, right? He changes direction. Why am I using the inflection point? Because when I start doing graphs that look like this, they don't really have a vertex. They have a direction change. And that's going to be important to us. So we're going to refer to these as inflection points. The next thing is the domain on these guys. Guess what? The domain on these, my little arms are out here. I'm going everywhere this way, everywhere this way. It's all real numbers. Domain on these guys, all real numbers. But my range is a little bit different. Remember what range does? Goes from the bottom lowest point to the highest point. So our lowest point is at 0. Our highest point is at infinity. Is that cool? Everyone remember this. Nice and easy. Light work. Now we're going to mess with this dude. We're never going to make this chart again. We're just going to mess with him. You ready? Here comes our first one. We're going to do these two guys. You got 2 graphs. Now, we're going to start doing what we call shifts, right? We're going to shift this guy around. We have some choices. We can shift our graph up and down, and we can shift it side to side. Now, we're going to start with stuff inside the grouping symbol. In other words, it's inside the sticks. Do you see what I'm talking about there? So we're talking about stuff that is inside the sticks. And if stuff is inside the sticks, does anyone, I want you to actually turn and talk for a minute. Do you remember, does it shift your graph up and down or side to side? Turn and talk to your neighbor and see if you think you remember. Does it move your graph side to side or up and down? Turn and talk. Right now, turn and talk. Remember? It does. I heard so many. It is side to side. Side to side. And you know what we call that? A horizontal shift. Now, a lot of your teachers, especially if you did algebra 2 K, they started using words like H, letters like H and K and all that. You know what? I don't do the H and K. I just need you to know where things live. Now, I have a goofy way of talking about this. It shifts it side to side, but it doesn't do it the way you think it would. So here, right now, here is my home graph. He looks like this, and he looks like this. And you feel like, okay, x plus 2 should shift it to that way, and x minus 2 should shift it this way. But here's what I need you to remember, and this is so goofy. Anything in grouping symbols is there for a reason. And the reason is that it is naughty. It's in time out. It's been put in timeout because it's trying to trick you. It doesn't move it the way you think it would. It does it opposite. So if it is x plus 2, watch what's going to happen. It's going to shift it 1, 2 that way. Does that make sense? And if it's minus 2, it would shift it 1, 2 that way. So I'm going to draw it on here for you with you. You guys ready? So here's what it's going to look like. I'm going to do this guy in red. So here he is in red. It's going to take our inflection point. That's my home base. I move it over 2, and then I've got this guy just like that. And if it's this guy over here, I want him to be blue. It's going to do it the opposite way, right? So from here on out, if it's ever in grouping symbols, it's naughty. It moves it naughty. Are we good? Okay. Here comes the next one. What about if it's outside the grouping symbol? Let's start with this one. Y equals the absolute value of x plus 2. And I'm going to do this one in red. Y equals the absolute value of x minus 2. Outside stuff moves it up and down. This is called a vertical shift. And you know what it does? It moves it up and down exactly the way you think it would. You know why? Because it is not naughty. It's not naughty. It's not in the timeout. It does it exactly the way you think it would. So if I was doing this guy, I start with my home base. I'm going to shift it 2 up. Boom. If it is 2 down, right here, super easy. Super easy. Yeah? Okay, so far so good. We've done a lot of stuff. We've done stuff in the grouping symbols, stuff outside the grouping symbols. We've got 2 more things to do. Are you ready? What happens when it's just attached in the front? So let's do this one. Y equals 2 absolute value of x. That's really long. And y equals 1/2 absolute value of x. I'm going to move this. Does anyone remember what that stuff does? Anyone remember the stuff on the outside? Say it. Yeah, it does. Stretch and compress. So it makes it, here's the words I'm going to use, skinny and fat. If it's a big number, it's stretching your graph and making it super skinny. So that is called a stretch. That is called a stretch. And it makes it super skinny. The bigger the number, the skinnier it is. It's like slope. So here's our normal one. I'm going to show you the normal one. It looks like this. That's the normal one. Let's look what happens when I stretch it. I start here, but instead of going up 1 over 1, I'm going to go up 2 over 1. Up 2 over 1. Look how skinny he's getting. He gets super, super skinny. Right? The bigger the number, the skinnier it gets. If it was 5, it'd be going up 5 over 1. It gets super skinny. If it is a fraction, it's called compression, right? And you know what it's doing? It's squishing this guy down. Imagine you're taking your hands and you're pushing it down, and it's going to make it super fat. It's going to go up 1 over 2, up 1 over 2. Look how fat he gets. Up 1, and I'm not judging him. Like I'm not doing that to him. Right? Whole numbers make it skinnier. Fractions make it fatter. Are we cool? We got one last thing to do. One last thing that can happen. Oh, look at this guy. I don't like this. I'm going to make it bigger because it's hard to read. Our last one, y equals negative absolute value. Any memories? What he does? He reflects it. He flips it. He flips it. This is called, it reflect, oh, what the holy hell happened there? That was a little terrifying. Reflect over x-axis. In other words, it flips it. So normally it would look like this, but now it's going to flip upside down and look like that. Yeah, super easy. Okay, here we go. Get out your little whiteboardy thing. We're going to do 3 of these. Sammy, are you ready? Get this out. We're going to do 3. Very exciting. Here we go. You ready? Right. Take a deep breath. We got this. So easy. So easy. Light work today. Light work. F of x equals. We'll start easy. Now, tonight, we're not going to need to put the parent function on, the home base. Tomorrow, we're going to start with the home base, and then we're going to move it because these are trickier tomorrow. But for today, I need to know what my beginning inflection point is. My beginning inflection point is always 0, 0 on an absolute value graph. I have to kind of memorize that. Now, I'm going to shift it around, right? I'm going to do it exactly like it tells me. It's going to tell me to shift it 3 this way and 2 this way. So I'm going to move this dot. I'm going to move it 1, 2, 3 this way, 1, 2 that way. Now draw in your graph. It's up 1 over 1. You know how I know that? Because there's nothing here. There's nothing there. Just 1. Just 1. Does yours look like mine? How about our domain? All real numbers. Nice and easy. Domain is nice and easy. I'm going to come around and look. Please put the range on right now. We haven't even done the graph. Do the range. Do the range. Phil, do the range on this one, please. Write your range. Remember, it's lowest to highest. Use the range. You have to do that. Solid bracket? Yep. Nice, nice, nice. 2 to infinity. How's it look? Are we good? Yeah? Okay. Let's go. Let's get a little trickier. We got this. Here comes your next one. F of x. Be a little faster than normal. Remember that 2/3 is like the slope for us on these ones. Do you need a Okay, don't forget our domain and range. See, I told you. When you push up to you, you're like, But you know what? We're not doing this. We're not making a chart. Ugh, that would be terrible to make a T-chart. That would just be, that would be a nightmare. That would genuinely be a nightmare. So here's what I know. I always start off, for me, I start off with my home graph, my home base, my parent base. Now what I'm going to do is I'm going to shift this guy 1 this way, 2 down this way, and now I know I'm going to go up 2 over 3, up 2 over 3, up 2 over 3, other side, up 2 over 3, up 2 over 3. He should be pretty fat. He should be pretty fat. Look at him. Oh, he's beautiful. He's beautiful. Thanks, John. How'd you do? How'd you do? Good. Our domain, all real numbers. Our range on this one, -2 to infinity. Woo! We got 2 last ones, and then we're done for the day. I like this next one. Here we go. Let's put it all together. We're bringing this baby home. If you are ready, f of x, you know what we haven't done yet. We haven't reflected it. Look, so many 2s. So many twos. Twos, twos, twos. Be careful on your range on this one. This one's going to be a little bit of a trick on the range. Domain and range. Always start with my home base, my home inflection point. Are we ready to take a look? So here I go. I am going to move this guy. I'm going to move him 2 that way, 1, 2, and 2 this way, yay. But I also know my slope normally would be up 2 over 1, but I'm going down now, right? So my slope on this one is going to be downwards, 1, 2 over 1, 1, 2 over 1. Look at that. He's pretty skinny, and he's facing this way now. Boom, he looks like this. My domain is still all real numbers side to side, but my range, careful on this one. It's bottom to top. Look, I already did it wrong. The bottom is now in negative infinity, and it goes up, 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 and it hits at 2 like that. Watch those ranges on that one. The last one I want you to do is my favorite. This is crazy. Write the equation of that. Here's what I'm going to tell you. You know that you need something out here. You're going to need something inside here. And you're going to have something out there. Once you know what all those little parts do, writing this equation is pretty easy, right? So that's our beginning point. And here's where we are now, right? I love this problem. I love it. Beautiful. Love that. See? If I started here, you would have been like, I can't. Now it's light work. Here's what I did. I moved this guy 1, 2, 3 jumps. And so I'm putting that guy here. So that was +3, remember? Oh, sorry. +3 in here, remember? He's naughty. He's naughty. And then I went 1, 2, 3, 4, 5. So I've got the 5 here. And he flipped over. So look, it's already done. Your homework is super easy. It's these. I would ask you, though, to do me a favor to get full credit tomorrow. Please put domain and range on. I forgot to write that on. Do domain and range. Answer keys in front of you. Light work. You will finish before the period's over. And yay, yay. I told you. This one's good. Tomorrow, maybe not as much. But today is good. Goodbye, friends.